So as Stephen mentioned, well, first thing I should say is that I always really like doing Research Showcase and being here. It's so fun to see everybody and what they're working on. Okay, so I'll try to live up to my colleagues' good performances so far. And one of the ongoing research projects here at GSLIS is our annual participation in what's known as the Text Retrieval Conference, also known as TREC. And my aim today is going to be very, very high level. But what I want to do is to give you a brief overview of what TREC is, and then specifically what the role of people at GSLIS has been with respect to TREC for the last couple of years, and then also moving forward. And so when I say we, there's a few folks listed at the bottom of the slide there. Really, our participation in TREC, it's a team effort. Lots of people were involved. These are the folks who decided that they wanted to have their name attached to this. So there are other people too, but thanks to everyone who participated. It's a lot of fun. You can see it's both faculty and students, and basically we get together and we do a lot of brainstorming and coding about how to make search engines work well. That's basically what we mean by text retrieval, by information retrieval. How can we make search engines work better than they do currently? And as the name of the talk implies, most of the work that we've done for the past couple of years have focused on issues where time plays a central role in particularly the notion of relevance, right? We're often eager in information retrieval to help people find relevant information. Well, in these cases, we're dealing with kinds of information where the information itself or people's information needs have an inherently temporal dimension. So, quick review or overview of what TREC is. As I said, it stands for the Text Retrieval Conference. It's organized each year. It's been going on for 22 years now. Organized by the federal government, National Institute for Standards and Technology. And each year, NIST defines some number, usually around 10 or so, so-called tracks that are going to comprise TREC for that year. And each of these involves doing retrieval over a particular kind of data for a particular kind of problem. So we have web search, which a lot of us are familiar with, search for legal documents, that kind of thing. For the past 2 years, GSLIS has focused on the items on the right, the microblog track and the knowledge base acceleration track, which is also called the KBA track. And so those are what I'm going to focus on in the next few slides. Okay, so the microblog track, this basically, we don't like to call it the Twitter track, but that's basically what it is. Let's see, so with the microblog track, the scenario that we're working with is we have a person who's interested in assessing what's being discussed on Twitter with respect to a particular topic at a particular time. And so this slide sort of schematizes the situation. So you might think of a journalist who's doing reporting. This was the corpus that we were using was collected right after, I think, the earthquake in Haiti that took place in Haiti a couple years ago. And so one of the queries that we treated was when Jean-Baptiste Aristide returned to Haiti, and we wanted to try to retrieve tweets, that is documents, that are relevant to that particular request. So in the slides that you see here, you see this slightly unusual scenario that we have given these data. So in both panels, left and right, each item, whether it's a dot or a bar, corresponds to a document, so a tweet. And over on the left, this is what we are pretty good at in the information retrieval world. These are basically the probability that we think that this document might be relevant given the lexical information that it contains, right? So these are the kinds of scores that we can compute based on textual similarity. And a standard search engine would just rank the documents, as I've done, in decreasing order of their probability of relevance. And it's not a solved problem, but it's something we're pretty good at. The thing is, in microblog retrieval, we've got a second source of information as well, which is schematized on the right. So in this case, each bar corresponds to a document. I'm sorry, it's a histogram. And so what we see is, here we've got document age. And we can see that document ages, that is, of those tweets that were retrieved for this query, aren't uniformly distributed over time, right? We've got a spike about, I think those are hours. So about 15 or 20 hours ago, and then there seems to be another mode about 80 hours ago. And so the question that we've been pursuing is, how can we take both of these signals, the sort of semantic, the lexical features, but then also marshal this temporal information and marry those together into one ranked list in a principled way, and then a way that also capitalizes on the idiosyncrasies of the domain here. So the KBA track, the knowledge base acceleration track, is predicated on an interesting factoid. So in a recent study, John Frank, who organizes the track, found that on Wikipedia, the median time lag between when a document is created and when it is integrated into as a citation in a Wikipedia page is over 1.5 years. And so there's this big lag between when, say, a blog post comes up and when somebody on Wikipedia author decides that it's worth citing that in a particular document. And so the idea here is that making the quality of Wikipedia good is an important goal, and that we can help this quality emerge more quickly by routing appropriate information to Wikipedia editors. So in this case, we have a filtering task. We don't have queries. Instead, in this case, we've got a Wikipedia page. This is, in this case, the Wikipedia page for a person named Aharon Barakt. And over time, on the x-axis in this slide, we've got documents coming in. And in this case, the documents come from lots of different places. I've got a couple of them there. We've got pages that were linked off of Bitly, stuff from news organizations, blog posts, all kinds of stuff. And our job as a participating team is that each time we see a document in the stream, we have to basically say thumbs up or thumbs down. Does this contain edit-worthy information with respect to this entity, Aharon Barakt? In other words, should we route this document to someone who's an editor of that Wikipedia page? And you can see I've divided the threshold, or I've put a threshold there. Everything in blue, I've decided will say yes. Everything in red will say no. Is that good? I don't know. It's hard to say. We did pretty well this year, so I guess it was pretty good. Okay, the core problem in knowledge-based acceleration, or at least one of the core problems, however, is the idea of entity representation. So here, we don't have a simple keyword query like we did in the Twitter search example and in search settings that we might be more familiar with. Instead, we've got this big idea of, in this case, a person, represented by a Wikipedia page. And we want to induce some sort of a probability distribution, that little equation at the top. So that basically means the probability that a document, or probability that we're seeing something relevant, given that we've observed the document D, and we are dealing with the model of Aharon Barakt at time t. So we want to try to figure out that probability distribution so that when we look at a document D, we can generate a number, and if the probability is high, we say, yes, that's a good document for this particular person. The tricky part here is that as time progresses, we get new information about the problem. So the sort of top steps there, does this have the little, yeah. So these top steps, right, this is the Wikipedia edit history. So the page actually changes over time. We learn some things about Aharon Barakt. The corpus that we were using spans about 9 months. So we can learn from that. And then likewise, of course, we see lots of documents coming through the document stream, and we would like to try to learn from those as well. And so that was really what we were focusing on there, was trying to figure out how can we remain confident that we're not drifting away from the topic at hand while learning, that is, updating our probability distributions in a principled way. Okay, and basically, I'm going to finish off now by saying that in all of these cases, what our approach has tended to be is, so I've used the buzzword big data that I kind of hate, but it gets on everyone's radar. So we have a lot of data. And by analyzing a lot of data in a fairly shallow way, we can actually come up with pretty good estimates for complicated probability distributions like these. So we're talking billions of documents in many cases. Moving forward, we're gearing up for TREC 2013 right now. Particularly exciting, We were invited to be co-organizers of the microblog track this year, so we're going to be getting to call the shots, not just work on them. So those of you who are going to be here next year, you should all come be TREC team members, and we'll have a lot of fun. Okay? Thanks.